What is time complexity?
The time complexity measures how the running time of an algorithm increases as the size of input data grows. It's a key idea in programming because it helps you predict and compare the efficiency of algorithms. Using time complexity, you can decide if your code will handle large data sets quickly or slow things down as data grows.
Why time complexity matters?
Even well-written code can become slow if the underlying algorithm isn't efficient. Understanding time complexity lets you pick better solutions for sorting, searching, or processing data, making your programs run faster and use less resources. This is especially important when working with large files, databases, or real-time systems.
Explaining Big O notation.
Big O notation is a standard way to describe time complexity. It uses symbols like O1, ON, and ON squared to show how an algorithm's runtime increases with input size. For example, O1 means constant time, while ON means time grows linearly with input. The smaller the big O, the faster your algorithm handles large data.
Comparing common algorithms.
Consider sorting algorithms. Bubble sort takes O cube n squared time, making it much slower than merge sort, which works in O cube n log n time. For searching, linear search is O cube n, checking each item, while binary search speeds things up to O log n by repeatedly dividing the search space. Choosing better algorithms leads to significant speed gains.
Tips for optimizing your code.
Analyze your code for bottlenecks. Replace inefficient loops or nested operations with more efficient algorithms. Use built-in functions that are optimized under the hood. Always consider the input size, because solutions that seem fast with small data can become slow with larger sets. Mastering time complexity helps you write smarter, faster code